It starts here and ends up here. It starts here and ends up here. It is everywhere in our modern world. Steel. And a lot of it is made right here at Nucor Steel Decatur. By combining exact chemistry with advanced technology, we are better at making steel than we have ever been. We can make it lighter, stronger, and more durable than ever before, which means our customers can do things with steel they have only dreamed of. We aren't just making steel at Nucor Steel Decatur. We're helping our customers make the things that steel goes into, and the opportunities are limitless. Steel has played a major role in the progress of civilization, and the history of steel starts in outer space. Thousands of years ago, humans discovered that certain rocks could be forged into useful tools. Those rocks were meteorites, and they contained a very special ingredient, iron. But it turns out that the best source of iron isn't from outer space. It's right under our feet. Iron can be extracted from iron ore, one of the Earth's most abundant resources, by heating the iron ore to extreme temperatures. And then, by luck or chance, it was discovered that heating iron with charcoal resulted in an even more useful material, steel. The magic of charcoal was the carbon that it contributed to the iron. And the resulting steel can be worked just like iron, but is harder, stronger, and can be honed to sharpness. In the modern era, steel was primarily produced in blast furnaces that use iron ore, mined from the earth, as the primary feedstock. But starting in 1969, Nucor began producing steel using electric arc furnaces to melt down scrap steel and recycle it into new product. No matter the process, making steel is about achieving proper chemistries, and Nucor pursued a more efficient way to achieve those chemistries by recycling the abundant scrap that was piling up in our nation's landfills. Steel is infinitely recyclable, so we will always be able to turn the products of the past into the steel of the future. And that's good for the economy and good for the environment.
It's great to know that the scrap that we're recycling here gets turned into products that are used to help rebuild America.
Our advanced steel recycling process is capable of producing coiled sheet steel less than 1/16 of an inch thick, and we add alloys like columbium and titanium to give it the strength characteristics our customers require. Our entire recycling process from scrap to coil takes about 3 hours, allowing us to produce over 2 million tons per year. And our metallurgists, engineers, and research and development teammates are constantly working to increase our capabilities.
Chemistry is very important. Without getting too technical, if you have too much of one thing and not enough of another, you'll lose certain metallurgical properties that our customers need. So if our customers are making line pipe, they want a pipe that's not going to be brittle, so at cold temperatures it doesn't break. So we want to make sure we remove phosphorus. If we don't get those chemistries right, now you put a line pipe in the ground and you have potentially very bad things happen. They start running fuel through that pipe, you could have an explosion. So for us to get the chemistries right is vital that we're taking care of our customers. So I was a person just a year ago who was of that thought that steel was very simple or not that technologically advanced to make, but now I've learned that there are numerous variables that go into it that you have to account for when making steel.
Before we make an ounce of steel at Nucor, we start with safety. Our more than 700 teammates know that they must work safe, all day, every day.
Safety is the absolute most important thing we do here. We can make all the money in the world, but if our teammates don't go home the way they came here, then it's not working. Safety is our #1 priority.
It is the #1 priority up here, so because it can be a dangerous place. You just got to always be watching out for each other.
Safety is #1 here. It's good for the people and it's good for the company.
Safety is important because it's what we're expected to do. We're expected to look out for one another and our families expected of us.
The steel-making process begins when we take scrap and sort it for recycling. Different types of scrap have different properties. We carefully combine our scrap so it will recycle into steel to match customer specifications.
We have about 12 different types of scrap commodities and substitutes that we store out here in the yard. From there, we pick and choose what we're actually going to melt to help make sure the chemistries inside meet the customer expectations. From then, those products go on and to fit into automobiles, line pipe, as well as any sort of agricultural or appliance end-use products.
Recycling is only part of Nucor Steel Decatur's environmental stewardship. We have an extensive environmental program for both our steelmaking process and the local environment, all designed to ensure that our process is clean and safe.
Our mission statement really says it all. We are part of the community where we work. People forget sometimes that environmental stewardship is more than just a good feeling, it's also good business. We actually recycle our largest waste stream, which is our KO61, our baghouse dust. That's actually sent to a recycling facility where the metals are captured, and it leaves this facility as a hazardous waste, and after treatment it becomes useful product.
From the environment to our contribution to the local economy, to the thousands of hours our teammates contribute to charity and community work, Nucor Steel Decatur knows that good business should be good for everyone.
Just as important as the scrap we process and the steel we produce is the community in which we live. We are focused on taking care of the community in which we live and taking care of the customers in the surrounding area.
Once sorted, cranes drop the scrap into our 200-ton electric arc furnaces, or EAFs. Our 105-megawatt EAFs use 65,000 kilowatt hours to melt solid scrap into 3,000 degree Fahrenheit molten steel, a process that is energy intensive but significantly more efficient than making steel in traditional steel furnaces. After the EAF, the molten steel is moved to our ladle metallurgy furnace, where the chemistry of the steel is refined.
Right now we are in the electric arc furnace pulpit. This is the first step in our process where we receive scrap metal to melt down and make steel. So if you compare it to making pancakes, this is where we make our batter. We make a slag to start to remove some impurities. We get our liquid steel, which will move on down to the LMF. So if you back to the pancake analogy, that's where we would add blueberries or chocolate chips, whatever our customer needs for the metallurgical properties of that specific grade.
Next up is the caster, where liquid steel is poured through molds and cooled into long strands called slabs. The slab is the first time our steel starts to look like a product.
The casting is very interesting. I mean, look at the metamorphosis. We take the molten steel from the melt shop, and through our process, it's converted from molten into a solid. So it comes to us molten, and it leaves here into a bar.
As the slabs cool, they move onto the rolling mill. First, the slabs are reheated to approximately 2,200 degrees Fahrenheit, a temperature at which they are malleable. To reduce a steel slab into a final product requires pressure, a lot of it. As a slab's thickness gets reduced through our rolling mill stands, thousands of pounds of pressure, totaling upwards of 28,000 combined tons, are applied through each mill stand at speeds of up to 2,000 feet per minute. For example, a 3.5-inch thick, 100-foot-long slab can be transformed into a quarter-inch thick, 1,300-foot-long coiled sheet in a matter of minutes.
Right here is where we take the product, we run it down to the final gauge width for the customer. In the finished mill, we've got 5 rolling stands. Each stand we go through, we're reducing the strip thinner and thinner.
After the rolling mill, our products may be treated in our finishing areas, depending on our customers' needs. We have invested hundreds of millions of dollars in projects here at Nucor Steel Decatur, including $180 million on our state-of-the-art galvanizing line, where zinc is applied to our steel to reduce corrosion and increase durability.
We process by width and thickness for what they're going to do. Say an automotive car needs a certain thickness, a piece of decking to go on a outside building needs a certain hardness and thickness for the weather. That's why we put the zinc on it. We have different finishing process for end use. I mean, everybody needs something, a different thickness, a different width, a different lifetime for the product we're doing. and the flexibility for quality.
Once finished, our steel products are packaged and shipped via rail and truck to customers across North America.
We're standing in the galvanized shipping bay. These are where the coils are stored and packaged and getting ready to be shipped. We're shipping actually all over the United States and mostly in the east area and also to Mexico. A lot of times on my way to work or coming home or going to work, I'll see trucks that have a Nucor coil on the back, and it makes me proud that we're producing coils that are going all over America.
We got a lot of tons in the new World Trade Center, and that just, it makes you proud when you see stuff like that on TV. You know, I mean, you think, well, okay, Nucor's got material in that, and Nucor's got material in Yankee Stadium, and just, you know, we know this stuff, and it makes you proud to be a part of that.
I'm standing in front of the best steel in the world, made by the best team in the world.
At Nucor Steel Decatur, it starts here, and it ends up here.